This is one of the MinFault webinars. We're going to be talking today about how to build and maintain IoT management systems for scale. It's going to be run by me and Chris. Chris is a co-founder and CTO of MinFault. I'm another co-founder at MinFault as well. And we'll get started. So a couple things of business here. Let me make sure I'm clicking on the right thing. A couple things of business. There's a Q&A bottom at the bottom of your Zoom page where you can ask pretty much anything to us. We'll cover the Q&A towards the very end of the presentation. So we think the presentation will be about 40 minutes or so. And then we'll leave about 20 minutes towards the end to answer questions where Chris and I will kind of tag team all the questions that come up. Another note is that we will have a survey link sent at the very end. I think when you close the Zoom window, we'd love for you to fill that out. We get really great feedback every time we have one of these, and we tailor the content and what we do next to basically your feedback. And so we'd really appreciate it if you fill out that survey towards the end. So without further ado, Chris and I are going to take it over, basically talking about scaling IoT systems past the initial implementation. And so I'll introduce myself and let Chris do him. I'm Tyler. I'm one of the co-founders of MinFault. I worked at Pebble and I worked at Fitbit, basically as a firmware engineer. And I always found myself working on firmware tooling and efficiency, developer tools, making developers happy. Chris?
Hey everyone, thanks for joining today. I'm Chris Coleman, co-founder and CTO at MinFault. As Tyler was saying, prior to starting MinFault, I've spent my entire career in the embedded space, working on servers and custom ASICs at Sun Microsystems to wearables at Pebble and Fitbit with Tyler. Across the board, I've always been a firmware engineer who's enjoyed a good bug or problem a little bit too much, I would say. So weird battery life issues or strange resets or devices failing to connect to Bluetooth would eventually make their way to my desk at those companies. And so let me tell you, as the number of devices grow, the number of individual reports you can look at certainly doesn't scale. And I'm really looking forward to chatting with you all today about some of the processes that Tyler and I have built out in the past and seen work well.
Yeah, thanks. And yeah, and we write extensively on Interrupt, the MinFault's blog, interrupt.minfault.com. You can read Chris's wonderful articles on how to debug hard faults and connectivity issues. And I've written some stuff about tooling as well. So what this topic today that we're going to be talking about is not just to give an overview. Francois gave a really great webinar on launching an IoT device. And that starts from kind of the beginnings of building hardware all the way through launching the product. It was a great webinar. Check it out if that's interesting to you. But what today is we're talking about is basically the ramp from, you ship the device, now you have 100 or 1,000 out in the field, and you need to scale that to 10,000, 100,000, a million devices. That's what we're going to be talking about today. It is a little bit higher level. Scaling to a million devices, you can't just talk about code and the nitty gritty, but there are some best practices and some high level guidelines that we'd love to talk about. And so we're going to basically chunk this up into 4 different topics. 1, how you build and scale your firmware team. You can't just have firmware engineers on your team when you're actually trying to build a large scale hardware company. You need software engineers and many other people. And so we'll talk about that. 2nd, how do you debug in production? There will always be bugs that pop up in production that don't happen in-house or when the device is on your desk or connected to a debugger. So how do you go about doing that, and what are best practices there? When you have more than 10,000 devices or 100,000 devices or even a million, just scary. How do you scale your data systems to ingest all of that data? Because 10 devices and 100 devices or 1,000 devices is incredibly different than a million, and you still want to be able to monitor all million of them. So how do you scale the data? And then last, how do you build usable systems that everyone in your company can use, even if they aren't just a firmware engineer or aren't a firmware engineer on the firmware engineering team? So first thing we'll talk about is the firmware team makeup. I firmly believe that a successful and modern and growing firmware team is made up of more than just firmware engineers. I would almost argue that like the title of a firmware team should be the device team or something like that rather than just the firmware team, because it kind of alludes to just having firmware engineers. So today's firmware and hardware experience is you build a connected device. It's generally connected nowadays. Before it wasn't connected, it was just a self-isolated, watch that just told the time, for instance. But now it connects to a cloud server through some gateways, mesh networks, has a backend service, and it performs action based off of that. To kind of build that whole end-to-end cycle, you need hardware engineers, electrical engineers, firmware engineers, and also software, cloud, data, DevOps engineers to build just this product experience. But as we all know, these connected devices, when you have thousands, tens of thousands of them in the field, they sometimes fail. We have no way generally to find the information on how it failed, because monitoring the hardware is almost always an afterthought, at least in the large companies that I worked for in the past. Monitoring was kind of a thing that we were forced to build after we had 10,000 devices in the field and customers, and customer support was overwhelmed, and we just had to do something about it. And so, what we learned was that when we shipped to 10,000 devices, the firmware was never perfect. The customers, they're going to have issues, whether that is connectivity to their random phone that they use. We're going to have to update the firmware due to security vulnerabilities. And all of these issues that customers have, pretty much every single one, they can't be ignored. You have to triage them, you have to be able to debug them, and you generally have to fix them, or else you will just have a bad product experience. And if you're not prepared for all of the customer support issues and all the bugs that your devices will experience in the field, like, it will consume the feature development. And so this is kind of how I feel the modern firmware team should be structured. You need to have more than just firmware engineers. And I'm going to let Chris speak, but I know Chris for like a whole month was basically writing SQL queries as a firmware engineer on the team. And I know he'd love to tell you more about it.
Yeah, there was, when you say kind of halting feature development, I think back to a time at Pebble where we started to kind of ramp up from that low number of thousands of devices to tens of thousands and hundreds of thousands of devices. And some of the connectivity issues and reports we were getting didn't really scale. Only halted feature development for a period of time to get metrics in place to understand what was happening. Then my job became, for a period of time, really just writing SQL queries to pinpoint what type of connectivity issues we were facing. Were they related to firmware versions or phones or problems like that? So in general, I think the sooner you can start to get some of these pieces in place, they don't consume all of the time up, and you can cycle back to actually working on your product and building new features, the better. But definitely all of these pieces here in and of themselves can wind up consuming full engineers' time.
Yeah, and like, as you can imagine, the electrical and the firmware engineers are doing stuff before the product is shipped and before firmware is shipped. QA and test, ideally you have testing for a month or two. But kind of these last three, software, DevOps, data engineers, they're really the people you hire when you're scaling your product, and they become hugely impactful when you have more than 10,000 devices.
And sometimes it's a collaboration there, Tyler. I was just thinking an issue we faced on one of the products I worked on, where we launched it out into the field and we started to see that 3% of the devices were experiencing a brownout. And it boiled down to being a diode that we had selected, where the peak current, when lined up with just the right silicon, didn't work out well. It browned out the chip. And it was kind of a combination of the data that was there and the electrical engineering skill set that led to figuring out what the root cause was in the first place.
Full stack development. I love it. So I want to quickly tell a story about how we used to add metrics. And so let's say you get you get a lot of support requests. I think almost every company does that uses Wi-Fi or Bluetooth, that the Wi-Fi for performance isn't good, or something is wrong, or their devices aren't connecting reliably. And so as a firmware team, we've wanted to in the past, you probably do, you want to add a Wi-Fi RSSI metric to your firmware. And so that the team, the company can assess whether this RSSI is improving or going down between releases, and also just how it's tracking. And so you add a metric to your firmware that's usually in a struct, or it's in a protobuf structure, or it's sending JSON, whatever your flavor. I have opinions on that. But you build this firmware, you tag it, you test it internally for like a month or so, and then you deploy it to all of your products. but that data doesn't get back into a database. Like that's not the end of the story. You need to update your parser that's actually going to parse this struct when the packets of data come in from the devices. And then the cloud team is probably going to be the one who builds that parser. Or maybe it's a really enthusiastic firmware engineer that's writing a web application that's doing that. But that iteration of the software is going to have to be tested as well and deployed to the cloud. But now that parser just can ingest the data, but it has to put it somewhere. And so now even the companies that I work for, now we need to update the data warehouse schema for a different version. This takes its own testing. This requires, I need to answer the why. Why does this need to be updated? Why do we need to update our massive data warehouse schema just for this RSSI metric? That takes a while. And then if you really go above and beyond, building a GUI for ingesting this data as a firmware team or maybe as a product team to understand, is the RSSI getting better or not? All of this cycle that we went through pretty much every time we wanted to add a new metric to our firmware would take about 1 to 12 weeks, and then an extra 1 to 4 weeks to actually get that data into the data warehouse, through ETL pipelines and being able to query it or view it in a UI. And this is generally the best case. This is if you tracked it correctly the first time. What we found time and time again is we would usually track a metric incorrectly and have to do this whole thing over again, which was a pain. And so what I'm excited about in Memfault and what Chris is probably mostly excited about with the SDK that he's built is that you can actually add new metrics in firmware with just 2 lines of code and then no cloud engineers. I'll let him talk about it.
Yeah, I often wound up being the person in the past when we were rolling out a new Bluetooth chip or dual sourcing component or trying to look at things. I wanted to get quick metrics out there to understand, was it working the same as before? Were regressions introduced? And as Tyler was saying, a lot of that process can wind up being tricky when there's multiple teams involved and you have to coordinate releases and get the right work scheduled across the things. So the approach we've really taken at Memfault to tackle that problem has been getting this one data pipeline in place where we embed decode information for these metrics in the debug information of the ELF that's compiled. And then server side, use that as our decoding engine. So there's no teams that have to be involved. The data can just be proxied along and a firmware engineer can see right away how many I2C transactions are failing or how much heap is in use or what's happening on their system. So in general, yeah, very excited about the approach. I wish I had it in the past.
Yeah, it really enables if you just want to have a metric for like a nightly release, you can pretty quickly add it, get the data, understand it within a day or two, and then even remove the metric if you found it's no longer relevant. And I know many times in the past, we would build one-off releases at a previous company. We would lose the protobuf definition, and then we could no longer decode those metrics ever. Or we'd have to—
It reminds me of those beta builds, Tyler, where there would be some firmware that someone had built that the protobuf files were never uploaded for, and then none of the data could be decoded, and then there were 100 people in the office trying it out.
Nightmares. Anyways, no longer an issue on Memfault, which is why one of the reasons why I love the product. So once you have the team and the new metrics, and you can kind of be self-sufficient as a team, and you're scaling your devices, now you need to actually be able to debug these in production, which is the next topic we're going to be talking about. So with 10,000 devices in the field, there will be bugs. Many of them will be weird, but many of them you actually won't be able to reproduce internally. And you will truly have to debug them in production. And so one thing I want to get from the readers, which we're going to take a poll right now, let me make sure that I can do this, is how many issues have you seen only surface in production? I'm very curious to hear the answer from the readers, and I'm sure you all would be curious otherwise as well. I'll give you another like 10 seconds or so for people to submit their answers. Cool. I'm gonna click end. Great. So it looks like 0 people said 0 issues have only surfaced in production. And then it's split between 1, 5, 5 and 10, 10 and more. And so, yeah, pretty much everybody has seen many issues in production. And I'm very curious to understand, if the 10 or more means 100 bugs or about like 12. Cool, we're gonna continue. And yeah, that's exactly what I've seen. I see so many bugs that only surface in production. I know Chris can speak endlessly, probably for hours, about the bugs that he can only see in production. You'll hear more about them, but I want to paint a little bit of a picture. So the reason you can only see them in production is because a lot of internal testing tests with a single phone, maybe a single transport, and a single firmware. And generally, it works. At Pebble, we would test with iPhones. Most of the company was using iPhones. And I think most of our releases, we would ship them, and then Android would be busted in a particular way, or a particular version of Android. And then we keep wondering to ourselves, as we ship these firmware and it gets to greater number of downloads, more customers are using it, the topology changes, or maybe we add a new feature, we wonder if it ever worked. And then that is truly why we have to debug in production. And what we learned is that it's just impossible to simulate all the environments and all the matrix of possibilities that your device will experience. And I'm going to leave it to Chris to tell more of these horror stories that he had to deal with.
I'll give a few classes, or three of my favorites, Tyler. Just too many. I could be here all day. But the one of the ones was when I worked at Pebble, we decided to expose a Compass API to end users. So they could get a compass on their watch and see what was happening, which, if any of you built those out before, winds up using a digital magnetometer that reads magnetic field strength. Well, the magnetic field strength around the world is different. And so the impact of other metals, for example, what's on your PCB, can impact your calibration more or less in different places. So when we deployed to the field, we found out that users in South Africa were having a hard time getting the compass to calibrate, had to dig in and look in and find those types of things. Then there's types of problems. I think my second favorite is problems that I don't really know how you would have tested for them. Interoperability issues there's the picture of the compass. Interoperability issues that happen after you ship. So for example, at Pebble, we launched a watch, one of the Bluetooth supported the 4.2 stack a little bit before the iPhone 7 launched, which also supported the Bluetooth 4.2 stack. There wound up being some interesting interoperability issues when two different MCUs were talking that for the first time that we wouldn't have been able to look at beforehand because the phone literally didn't exist. And then I think there's other kind of emerging ones that I've enjoyed watching our customers debug and look at. For example, asset tracking applications where you're talking LTE. There's something like 800 mobile network carriers around the planet with all their own little special secret sauces and the implementations they have and the stacks that are there. And if you're doing shipping or some commercial logistics stuff, you wind up in situations where, when a ship is docked outside a port in Virginia, it behaves differently than a port in Boston. And those have been like very interesting issues to debug and look into. At the end of the day, if you're building a connected application, I'm confident devices probably experiencing some issues out there in the field. And the best thing you can do is get some monitoring in place early to understand the scope and hone in on what issues need to be fixed and looked at.
Yeah, thanks. I was just talking to a person at the Boston happy hour last week or the week before, and he was saying they were building parking meter infrastructure, and every time the buses in San Francisco would pass by, their parking meters would freak out due to the electric interference of the bus lines. And I thought that was this is exactly the type of thing we're talking about here. Cool. And yeah, so these bugs that kind of either only surface in production or very, very rarely surface, we've enjoyed giving them a name, 1 in 10,000 hour bugs. And these are bugs that genuinely come up, on average, if you do statistical math, once every 10,000 hours. And translated, the inverse of that is this bug would take 416 days to surface on a device if you were testing this, on your desk, connected to a debugger, trying to reproduce it. I have seen poor souls try to reproduce a bug, a class of this style of bug, a 1 in 10,000 hour bug, on their desk, and they would try to reproduce this for weeks on end. And somebody in the company would experience it every so often, but that person would never be able to reproduce it. But with 10,000 devices in the field, that issue is hit every hour. With 1 million devices, every 36 seconds. And what this is translating into is that if there is a really bad bug, maybe it's corrupting the flash file system, which we've been through before, or it's doing something that just doesn't generally happen internally, you can miss these catastrophic issues, and they will not be hit during internal testing. And so you need to be able to build a system that captures all this information externally, and when devices are no longer at your desk. And so bugs will always exist. Your vendor libraries and your RTOSs will always have bugs. They will always have security vulnerabilities. You know, they do update. Developers are human. FreeRTOS and Zephyr will always have bugs, and that's why they have patch releases. And so firmware updates are a necessary evil. You know, every time you update a firmware, you're risking adding a new bug, even adding a new 1 in 10,000 hour bug. But you're also probably fixing more, hopefully fixing more than you add. And what we at Memfault suggest is that at least companies are starting to track the number of issues, whether that be crashes or disconnects, asserts, watchdogs, you know, flash write errors, any sort of error in your system. At least count them and gain an understanding of whether these things are going up or down between releases. And when you experience those issues, capture as much data as possible. We aren't going to talk in detail about how to monitor your IoT devices. It's more so just saying do it. But I did give a talk a couple years back about how to monitor IoT devices at scale. Even though it's 2 years ago, the content is still very relevant, if not more relevant. Maybe I've forgotten some of the enlightenment that I had back then, but it's a great webinar. I suggest checking it out. And yeah, moving on. So now you have 10,000, 100,000 devices in the field. You're sending data back because you're counting the number of issues. You're trying to capture as much data, whether it's logs or core dumps. But now you need to scale all of this data that is coming into your system. And I believe that ingesting the data is actually relatively straightforward. If you want your devices to send you, you know, log files every minute, or sorry, not every minute, every hour from 1 million devices and shove them into AWS S3, it's pretty easy. Maybe expensive, but what's actually hard is processing them and grokking them, basically. And so I know Chris has been through this quite a bit with building a bunch of systems, and I'll let him talk about it.
Yeah, it's interesting because if you're building kind of traditional monitoring for a cloud application or the service you're running on a cloud, most hardware companies aren't at a Google or Facebook scale. The amount of data, kind of walk through an example here, but if we have 100 servers, which is a pretty modest deployment, and 100 metrics every minute, we wind up getting 600,000 data points an hour. Very reasonable amount of points to throw into a database, query along, and look at. If we have a modest IoT fleet that's deployed 1 million devices and we do the same thing, we might not, we might kill the battery life along the way, but we also wind up generating 6 billion data points an hour, 100 metrics from 1 million devices. There's no system out there today where you really want to put that much data into memory without kind of running the risk of bankrupting your startup or company or pieces like that. And so the way one has to approach monitoring on a IoT device needs a little bit more care than what we could traditionally get away with server side. And I think you have some more examples here too, Tyler.
Yeah. I believe that a successful hardware company that ships 1 million devices shouldn't need to spend an insane amount of money on just monitoring every one of them to make sure that they don't fail remotely. And so there's definitely better ways, and there has to be smarter ways. As an example, just some basic math here. Just to look at the scale that we're talking, if you have 1 million devices, 4-byte metrics, and you want to have 30-day retention on all of those metrics, it's like a terabyte of data, 1.2 terabytes. If you're trying to do that with logs, I think 64K is a reasonably sized log, 2 terabytes for 30-day retention. Again, that's not storing that's hard, but if you actually try storing 1.2 terabytes of data in a database, and that is, what you do monthly, or that is what you do on a regular cadence, that database will actually be super unhappy. Even in AWS, the largest disk you can get for a hosted database is 16 terabytes. That's the max size of the EBS disk. And if you're trying to do metrics, you generally need a time series metric database. If you're trying to do logs, you generally want Elasticsearch or a NoSQL database like Mongo. And you need to deploy separate systems for separate features. For storing core dumps, or for binary blobs, if you're trying to store like basically a Wi-Fi transport, if you want to replay what happened over the Wi-Fi transport or Bluetooth transport, and that's a binary blob, you store that in S3. But querying that data is still really hard. And so what we found is that downsampling the data as soon as possible is what we recommend. But even downsampling it isn't trivial. Yeah, there are some techniques to do it, which one that we really have enjoyed is kind of a device hourly heartbeat. It's kind of downsampling on the device. It's capturing all of your metrics and summing them up, or counting them, or averaging them, or finding the min and max over an hour or over a day. And then basically stamping that heartbeat with a specific firmware version, timestamp, and the device serial. And you're basically putting all those metrics in a single device heartbeat and sending that up. That can drastically reduce the number of metrics, because what we see a lot of times is the company will send a battery life metric only, and they'll send that sporadically, and then they'll send CPU sleep in a separate metric. But the heartbeat kind of keeps everything together and makes it easier to work with. Another thing that we have started working on and are now rolling out internally at Memfault is something called fleet sampling. And this is something that we think is very novel and will help companies kind of scale without really struggling to scale the amount of data. And that is, if you have 1 million devices and you kind of pick a subset of them, maybe 50,000 every single day, and you say, these 50,000, send me your logs, or send me the most recent core dump, or send me the metrics, and you switch that 50,000 devices every single day, you will see the majority of those 1 in 10,000 hour issues, and you'll get a very good idea of the metrics of all of the devices, but without basically having to stomach and ingest all millions of devices worth of data, which would actually cost you a decent amount. And you can use different frequencies based on different information. I know for us, there's different resolutions, whether you're doing logging or core dumps or sending certain metrics. You can basically specify at what resolution or frequency you want to send that data. And so even with 1 million devices, if only 1% of them, even 1%, are reporting in data, you will actually have those 1 in 10,000 hour bugs happen each hour, which honestly is amazing. If you don't have to pay for 1 million devices worth of data, it's great. And so I know, Chris, you had basically planted a bunch of asserts and various things and various firmwares and deployed them to a small subset of devices. And what we proved is that you only need one occurrence of an issue to basically solve it. If you have core dumps and if you use Memfault, basically, if you hit one occurrence and that occurrence gets sent back to Memfault, you can pretty much solve the issue with only one occurrence. You don't need 1 million devices sending you a core dump or the same log error line to get an idea of what's going on.
Yeah, I'm a big fan for those tough to pinpoint crashes, of getting some assert in there and rolling it out and capturing what's there when that failure takes place. Once you know that Bluetooth is kind of failing or disconnecting, and you can capture that, see what's happening, it can really help you dig into things. I think one of my favorite ones was it was probably an office only bug, I would say, but when we deployed builds inside our office, which was more or less a Bluetooth and Wi-Fi war zone, we had devices that would start to randomly disconnect or reset. And it turned out on the Bluetooth chip we were using, it would conclude no band in the channel map was good to use, and it would just kill the connection instead of kind of trying to hop around or stay on something else. But I feel like without the assert, I never would have figured that out.
Yeah, and I know many times we didn't exactly track what hardware was in every single device, or maybe that wasn't accessible with our systems, but you'd also go like hunting for specific hardware revisions or basically, timing violations in specific hardware, and you basically set an assert on there, and you just want to know the prevalence of those issues. And you just need an average. You don't need to know like exactly 472 devices. You just want to know like, one in every 1,000 devices has this issue. So very good use. Fleet sampling, honestly, has been great. So the last thing we want to talk about is, building what we're calling usable systems. But what that means is you have a data pipe. You're debugging in production successfully. You're sending metrics. You're sending core dumps. You are capturing relevant data that is relevant to other teams. You're capturing now maybe that RSSI metric, and a support representative needs to understand, is this device experiencing good or bad Wi-Fi connection? And they need to know that RSSI value. And so how do you get all of this data to be used by everyone in the company in a very easy or usable way? But first, I have a question, and I'm curious, at your company, how difficult is it for anyone to dig into this monitoring data if you're catching it? Let me get this started. So if I launch it, and so another poll, I'm curious, like if a customer support rep needed to understand firmware, health metrics, or whether it was experiencing crashes, can they do it themselves, or is it like, I guess Chris and I have done it before? Do they have to ask us directly, and then we have to pull the data? I know, Chris, you were just always the person people went to figure out, is this battery life bug real or is it something else? And it was great when we finally built the tools at Pebble for the support team to be able to use it directly. So good. All right, I'm going to end this poll. Great. I will share this one. So everyone can, I think, see these results. So a quarter of you don't collect monitoring data, which is good, or which is fine. Challenging for everybody. I think it's typically the use case. Only the firmware team can do it. Amazing. I'm glad that at least 50% of you at least have the data and can access it. But 3%, hopefully we can share some of the secrets that we've learned along the way to make this easy for the entire company to do it, because we've been successful. So let's move along. And so yeah, core of it, once the data is there, everyone will want it. And if you don't build very easily usable systems for everybody, your company, even as it grows and becomes more successful, will continue to go to the firmware engineers and ask, hey, can you pull this data, or can you get this battery life data for me? I'm really curious about what it is. Chris, I'll let you cover this slide, but basically, you can allow engineers, support, product teams, anyone at the company to look at this data, and it's very useful.
Yeah, I think at a high level, you've probably become that person who might run a script when someone's asking, what's the battery life of my fleet? Or, can you recover the stack trace for this issue, or decode these logs, or get these other things in place? When there's a small number of devices, the amount of times you're doing that is probably manageable. As the fleet size grows and gets up there, that can wind up becoming all of your time. And so the sentiment we've really seen work well. There was a point in time where I looked at every battery life issue that took place at Pebble or dug into it. Then there's a point in time where that was completely infeasible and there was no time left to spend on other things. And so where possible, the big thing we wanted to kind of cover or talk about here was getting tooling in place to enable others to answer those questions. So you can work on improving the root tools or improving features on the product or items that are out there. And that really spans cross-functionally from the engineering team, whether it's the firmware engineers or cloud engineers trying to understand why the devices aren't reporting data, to support team that's trying to answer those common questions that are popping up, to the product team and executive team that wants to understand, how many users are still using the product? Are we hitting our core KPIs that we want the device to work with? And, what things do we really need to focus on and improve next quarter or next year? So the right tools in place can really save not only yourself a lot of time, but a lot of the organization time. So you can get back to working on the actual product, which is the funnest part, right?
Yeah, and the different teams and domains just need different information as well. The engineering team needs to know how to fix it and what exactly happened. They may need the raw log files or the raw core dump, but the support team just needs to know whether this issue happened or not, and when it happened, and if it matches up with the customer story. And the product team needs to know, like, how prevalent is this issue? They don't care about looking at logs. You shouldn't have to train them up on logs. They just want to know how prevalent is this issue, and should it take priority over building this new feature that we promise customers, or should we fix these issues? So I want to tell my story about how I thought about going about this, and then why it didn't work at a previous company. So at Fitbit, I wanted to build easily usable tools for everyone at the company to use. And I started basically with local environments. And so everyone on the firmware team could download the firmware, create a virtual environment, install all the Python requirements, and then basically use Python scripts to run these scripts. Honestly, it was a failed experiment. For the firmware team, it was nice. People could get up and running pretty quickly with a virtual environment, and they could do everything they wanted. But not everyone is a developer at the company. And I wanted QA to use it. I wanted support to use it. I wanted PMs to be able to use it. And not necessarily everyone at the company. No one in HR needs to understand device health. But I wanted most of the people in the engineering org and peripherally to be able to use some sort of these tools that would pull battery life, or the existence of a crash. You can't give everyone GitHub access, and all these local environments are really hard to scale, distribute, keep in sync, and it's going to be a nightmare. I think I spent a growing amount of my time sitting next to people and getting their Python environment set up, and it was not a good use of my time. Another core belief that I have is that I think the firmware virtual environment system was one way to do it, but with all these other teams kind of needing this battery life data or needing this crash data, they were building systems along the side to make it easier for them. And so they were now building new data pipes to capture battery life data from devices. They were side channeling on whole different engineering teams to basically get this data. But I believe that there should be one way to grab the data, one way to use a tool. It should be the improved way. And if that way ever breaks, it'll break for everybody. And if anyone improves it, it'll be improved for everybody. Ultimately, what we found at Fitbit when we were trying to build these tools was that web applications were the way to get everyone on the same page, literally, get everyone using the same tools, and make it easy for everybody. Why is it easy for everybody? I can explain that pretty quickly as well. You can log in with SSO. So giving people access was kind of the first issue that we had to stumble upon. You can't give everyone GitHub access because that's a security issue, but everybody already has a Google login and LDAP login in your company. You can just use that system. There was no local environment setup necessary. So no one had to download Python or get Python installed, set up a virtual environment, and you didn't have to train people on how to use these things. One of my favorite stories of building a web application was an engineer who got tired of decoding logs that were encoded with protobuf on one of our new products. Every time this product would basically spit out a protobuf encoded binary log file, they would send it to him and say, hey, can you figure out which protobuf version this was using? And can you also decode these protobuf logs? Because I can't see what they are. And because he had the symbol files, maybe he built them locally. Anyways, he got so tired of doing this that he built a web application that people could upload these binary logs to this simple web application, probably 10 to 20 lines of code, honestly. And it would just spit the logs out in the UI. There it goes. He's freed up hours worth of his time per day with one engineering time, and probably spent a couple hours on building this application and deploying it. It was also great. And then on the right, basically, when we were building these web applications, we went from Heroku to a thing called Doku, which was like internal self-hosted Heroku version. And ultimately, once these things got productized, they were moved to Amazon, but still managed by me. And so web applications, they sound great on paper, and honestly they were, but what it turned out to be is the firmware engineers were responsible for managing all of these web applications because it was monitoring data. It wasn't relevant to the whole company, basically. And so what you had was me and Chris and firmware engineers like us, managing databases, managing infrastructure, dealing with security policies in AWS, and making sure that the disk size didn't go above 50 gigs, because if it did, it was really hard to resize the disk with EC2. Like, all of these things became our problems. And we didn't have a software engineer or a DevOps engineer on our team to help us with these issues. And if we did have an issue, the cloud team, software team was always too busy to help us out, at least within a reasonable time frame. And so, like, going back, a very important reason why having a software engineer or a DevOps engineer at least dedicated on the team or time sliced on the firmware team is super important. One of the rules of starting web applications is starting simple, and I'll let Chris speak to this because this is his bread and butter.
Yeah, the sooner you can get a cloud or DevOps engineer either on the team or dedicated time from the team, the better. But often you might be in a place where you want to prove this out or try it out. And I think something that's important to remember is you don't have to be writing some full-blown web service to start. I'm a huge fan of iterative approaches myself. It's kind of how Tyler and I tackled some of these problems in the past too. You can ask the cloud team for basic access to an isolated environment that's behind your company VPN. So you can kind of dabble and not have to worry about breaking anything. You can take that Python or Ruby script or whatever scripting language you're using locally and move that to a cloud application and just invoke it there. So instead of running it on your computer every time, like Tyler was showing there, it's running in a web application. You don't need a crazy front end. You can often get away with just plain old HTML and rendering some results there. This is kind of a screenshot of a very simple application we once had that took a firmware version. It took PCs and LRs, program counters, and link registers, would look up the symbol file behind the scenes and then print what the actual stack trace was. Very functional for what a bunch of folks were trying to do, but not a super crazy UI to have to put together. And then you can slowly, I mean, I think the part that's nice here, the part I really enjoyed about it in the past is then you can focus on improving the data that's collected or sort of how things work. I was finding myself always being the one to pull up core dumps at my desk to give people the stack traces that were there. Putting something in place that other members of the team could easily use gave me time to improve the data we're collecting and the analysis that actually took place in the core dumps versus being a robot more or less for a period of time. Same thing with battery life or other, maybe like you're interested in digging into heat utilization or bandwidth or connectivity. The sooner you can kind of put together some surface of information other folks can look at instead of answering questions about why did the battery die so fast or why wasn't connectivity working, you can enhance the data that's being collected on the device and the analysis of the tool to save so other folks can answer those same questions and you can focus on other things. So I think my pitch here is it's like a self-enablement thing. Like the sooner you can offload some of this so that it's getting answered for other folks on the team, the sooner you can get back to working on other things and improving the product.
Yeah, my favorite part about the web application was actually twofold. One, I never had to tell people to update their local repository or they were using an outdated tool because the web application was always up to date. And then alongside that, if there was ever a bug in the web app, I would basically solve it within 5 to 10 minutes, deploy a new version, and then I had no more support requests about that specific bug. Like I didn't have to tell people to update their local version or their tool or that they were using it incorrectly. That was amazing and saved me so much time. So if you don't want to build these web applications, that is honestly why we built Memfault. It is a web application that allows you to very easily send data to us, to Memfault, and then view it. And everyone can view Memfault if you give them access. And so we've designed Memfault to be used by PMs, by firmware engineers, by support members. We have different permissioning schemes for all those different users. We have an API that you can basically integrate it into other single tools. And it's honestly great. We like using it. It is the tool and the system that we were basically building towards, I think, at our previous companies, and that we were always striving to do. But we just didn't have the capabilities, the team, the UI engineers, the front-end engineers to basically build something that was usable by everybody. So the 4 topics we covered today, I'll skim over this: firmware team, debugging in production, how to actually scale the amount of data that you get in to your system and then process it and grok it, and then also building usable systems such as an early version of Memfault, like what we built, or Memfault itself, so that everyone can actually use these tools at your company. So that about wraps up what Chris and I wanted to talk about. We're now going to throw it over to a Q&A session. We have about 15 minutes to answer whatever questions you want to throw at us. And so if you go to the Q&A, if you click the Q&A button, you ask a question, Chris and I are going to tag team some of these questions, and we'll ask them to each other. But first, I think we just wanted to throw out a question that we typically always get. And what was, Chris, can you remind me of the question that you wanted to talk about?
Yeah, so I think one of the ones we typically see is, you're starting to build a product, getting ready to go to production. How much of this should someone think about before they ship the product, Tyler? Is it something to worry about later, or how do you see that?
So we basically talked to 2 different types of hardware companies, and I've worked for 2 different types. If we were a successful hardware company, and let's say our product went viral, we one day we sold 1,000, and the next day we sold 100,000. We're going to immediately hit scaling issues with our old systems that we have in place. And what is the worst is when a hardware company becomes successful by selling more devices, by having more devices send data, but then immediately start struggling because the processes weren't in place. And so in my opinion, you can't really start soon enough hiring the firmware team, giving them support with an extra engineer or 2, depending on what they're doing, building these usable systems, and not necessarily completely over-architecting the data pipelines, but at least allowing people to easily digest them, aggregate them, and get new metrics in place. If you as a company have a very clear ramp up period, because maybe you're a business or a hardware as a service company, or you're B2B, then you can build these at your own schedule.
Yeah, and I think it's something that's important to note. It doesn't have to be perfect from the start. Like, you have to have a way to OTA your device when you ship it to the field, because otherwise you're you're toast, because you can't update things. But getting something in place along the way as you're going to production that you can iterate on it's much easier to break it up than get to a point where you're drowning in support requests. You have no pipeline in place to get data out of the system and can't see what's happening. So the way I like to think about it is time boxing it and spending some of that time as you're ramping and getting the product out to getting the right systems in place to build stuff, get that MVP there. And then once you're in production, as things crop up, you have a system in place that you can add new metrics or put in new probes to get errors and root cause what was happening or taking place.
Yeah. Chris, I have a question here.
Yeah, go ahead.
Go ahead. I'll start. They're asking, what are the metrics that you suggest collecting when you're basically trying to scale your product? And so after 10,000 devices, like, what are some of the most important metrics?
That's a good one. I think there's, for all devices, there's some like key performance criteria that is expected to take place. If you're making a battery powered device, there's some amount of time that you expect the battery to last before dying. So getting a metric along that is super important. If you're using any connected, so I think the first step is asking yourself, what are these like key vitals of like, I know my device works. Is it if it's battery life? If you're doing LTE, I think everyone cares about the data budget, how much data is being sent over the air. So track how much data is being sent. Are there a small number of devices sending a ton of data? Are all devices sending a lot of it? So you can kind of dig in and figure out if you have to improve it. I always like, if there's a debate over whether you should use heaps or not use heaps, or whether you should use an RTOS or not use an RTOS. In general, I would recommend putting some metrics in place to understand, are you running out of heap? Are your stacks close to overflowing? Often it's hard to audit all of the paths that take place, or sort of all of the retries that may exist, or find all of the memory leaks. And those are very common bugs that wind up popping up out in the field for folks. So top 3 there, I generally look at is sort of like key performance criteria, some of the like utilization of the system. And the last one is if you're building a part that's supposed to last, are there any things that can fail over time? So for example, some of the most interesting bugs I've seen have happened 2 or 3 years after we shipped a product, because we were doing way too many erases on the NOR flash, and eventually got to a point where we started to corrupt sectors, kind of destroyed them, and then you had to stay away from that flash part or things like that. So if you're using components that might age or change behavior over time, having some instrumentation in place to understand if you're sticking within the budget to hit the lifetime you expect of the product can be super useful, because then you're not, issuing replacements and other things.
Yeah, to expand upon that, if you're tracking bandwidth, like when a hardware company is scaling, if they have recurring revenue model, if they're charging subscriptions, or they're basically charging the end user for the bandwidth, it's one thing. But if they're not, tracking things that cost the company money is crucial to track. And so tracking the number of bytes that are sent over LTE and seeing how much that changes between software versions or firmware versions. And you really don't want to basically like let a bug slip into production to 100,000 devices or 1 million devices that accidentally sends 10x the number of LTE bytes over the LTE network, because that'll be something that you really, really regret doing.
Sometimes there's like cool data you can feed back to the factory over time as you're as you're scaling out or building a product. I remember working with a e-paper display that its min and max current consumption on the data sheet varied by an order of magnitude, microamps to milliamps. And it turned out that there were a number of displays that we weren't catching at assembly time in terms of the amount of power that they were consuming. We can kind of see that from data in the field about devices that were consuming way more power than was expected. We're able to take those insights, feed it back to the factory so we could reject lots of bad displays faster, and get like the higher quality displays into the device, which led to better products in the future for folks. So often I think there's often a very fun feedback loop of the type of data you can collect as well to improve your product over time.
Yeah. Feel free to ask any more questions, guys. And we have one from John. Chris, you answered it privately, but let's answer it publicly.
Yep.
What was the SQL query-a-thon, the query month, the result of not having sufficient monitoring in place?
Yeah, so I think the example I was giving earlier on, we really didn't have any insight as to what was failing or how things were working or what was taking place. And so it really was catching up. Kind of, I think anytime you face issues, the first step is identifying what are the most common issues or what are the common trends. In Bluetooth, those questions often boil down to what versions of mobile phones are being used, what stacks are in place, and what was there. And so there's a lot of time doing that. In my case, we didn't really have a data engineer or anyone who was super familiar with SQL. I wasn't super familiar with SQL at the time either. So some of that was a ramp up on my part, understanding that and how to answer questions and how to submit data in a way that was easy to query.
I'm beginning to even understand that the more SQL and software engineering practices the firmware engineer has, like the more capable they are doing firmware related tasks and like solving firmware related issues, because honestly a lot of it just deals with tons of data nowadays. So there's one more question here. SJUR, sure. Do you have any particular OTA update protocols that you recommend? I guess I'll allude to that. It's not necessarily related to the topic here. But I think there's a couple features that we would recommend people have for OTA. One, stage rollouts, and so you shouldn't update all million devices all at once. And so if you want to be careful about it, you update 100 devices, and then 1,000 devices, 10,000 devices, and then if you're not seeing tons of issues or anything that is show stopping, if you say, oh, that's a bug that's existed for a while, that's fine to ship, then you basically scale it out to your entire fleet. The other couple of things that we recommend is having multiple banks to store a firmware update within, and so that you can easily roll back to a previous version. if the current one doesn't exist, or maybe it doesn't boot successfully, or maybe it gets into a boot loop and you need to roll back to the previous firmware. And that is something I think is now included in MCU boot and is in Zephyr by default, and a couple other firmwares. Anything else you add, Chris?
I guess that last point, if you find yourself in a situation where you think you have to write a bootloader, I would definitely recommend checking out MCU boot. It's kind of the default that's included in Zephyr now. It's a general purpose bootloader that deals with a lot of the things that you should implement, and then you don't have to roll your own. And as far as OTA update protocols, like actually transferring the data, that winds up being pretty specific to the transport that you're using. Are you using, Bluetooth or Wi-Fi or LTE? And generally, like for the chips that are out there, there's pretty good application notes of ideas to follow and practices to put in place there. What am I trying to? And if you're doing Bluetooth, I would say like pains of the past, don't embed the binaries in your mobile app because that will take. You might be at the mercy of an iOS approval process to get a firmware update out there. So there's some steps to think about there as well.
We've been there. We got one more question. Let's look. Give me 1 second. What feedback have you gotten from the executive team on web applications that has firmware metrics on it? Did they have a positive experience when they needed to use it? Did they have particular needs that the application didn't satisfy? They're typically. I see. Chris, when you built web applications in the past, PMs, product people, or product teams, other teams, like, did they find value in the web applications that you built? Like,
Yeah,
did they end up using them, and did they think the time was well spent?
Yeah, and I think that traces back to what you were talking about a little earlier, Tyler. Like, I don't think the executive team was super interested in the log decode web app from a kind of them going and checking it out level. I think they were interested when they found out that a lot of folks on the team were more efficient now because they were making use of it. Where I've seen the most success with like executive folks or sort of product teams logging into the tool has been apps that surface up kind of like high level themes. Like executives want to know, are the devices crashing? Are the devices getting, are devices getting better? They might see a lot of reports about, connection couldn't be established or Bluetooth wasn't working. And the web apps have been a great way to kind of answer those questions about, hey, things are headed in a positive direction as we roll more pieces out or things like that. So understanding a little bit about the use case and what folks want to see and having that on like a clear dashboard, I've definitely seen work well in the past, because generally what I found before at places I've worked or companies we work with is a frustration about lack of access to this data, like nowhere to get the answers or see what's there. And once that data is available, might create more questions or things to dig into, but has led to kind of people actually being able to make practical decisions on what to prioritize or invest in. If battery life isn't meeting expectations, it can be much better, much easier to kind of schedule or staff work to improve that, or Bluetooth or whatever it may be. Anything you'd add, Tyler?
Yeah, it's honestly a tough sell to the executive team because they wonder why the firmware team is not writing firmware. I know at Fitbit, I led the firmware developer experience team, which that was kind of our mission, was actually building web applications, building tools, coming down from the top down. Like the engineering leadership team was like, yes, this is a worthy investment. We have seen benefits from web applications. And then they basically gave us the ability to spend most of our time building these things and improving them over time. I know one of the most important applications that we wrote during Pebble and at Fitbit was the ability for anyone at the company to kind of maybe debug their own device, or at least kind of get an overview of what's happening with a single device. And so the CEO, whenever they would almost get tired of going to an engineer and saying, hey, this device just crashed, or I'm experiencing really poor battery life. Can you look into it? And the firmware engineer has to put everything aside, dig into it. Maybe they wouldn't respond sometimes, but we gave them the capability at Pebble and the Fitbit to basically pull up a single device's records and to look at certain metrics for that single device, and they were able to basically say, okay, cool, this is a real issue. Like I'm not being crazy here. My device did just reset, and stuff like that. And those are super useful. All right, I think that's all we have time for today.